So the first half of this chapter was talking about sampling distributions. If you were to summarize a sampling distribution, what that means, it's if you have a population, you choose a sample size. So if I had a population of this class, so 12 people, if I chose a sample size of 5, then it would be the combination of every combination of 5 people extracted from the population. So that's what a sampling distribution is. And you can solve for mean and standard deviation using the formulas that are given to you. So that's all sampling distribution. How do you solve for if I ask you, is the sampling distribution normal? How would you solve that? What would you need to check?
Plug it in.
So NP and N1 minus P must be greater than or equal to 10. What is the second condition that I have to check? So that tells me that it's normal. My sample needs to be less than 10% of my population. And the reason why I do that is to check and see that my standard deviation formula works. So NP, N1 minus P, that tells me that it's normal. And then sample size is less than 10% of the population. That tells me that the standard deviation formula will work. Yes?
So there was that one example about like the truckload of apples or something. And it was like, we're going to take 80 or whatever. So are we looking at like the all apples in the world?
Yes.
Or all apples in the truck?
So
All apples in the world.
So it's always all blank in the world.
Because we don't know how many.
Depends on what your population of interest is.
Seats and they picked 18 in population.
So that would be like the seats.
Yeah.
Like with things like that.
You have to ask yourself, what is the population of interest? Do I only care about the 200 seats in the plane, or do I care about every person in the world? Do I only care about...
If it doesn't say a
Some of them are
population,
kinda
can you
confusing.
assume that it means everyone?
If it's
Can you
the
assume
wall,
that
It would give you a number.
On some of these, on the
But
whole,
like
it
the
wouldn't
truckload
say
of apples,
population,
like-
but you say...
That rule, like,
50.
99.9% of the time is always going to check out. You just have to check it.
And then why would you want it to be, I'm confused, like,
Because the standard deviation formula doesn't work.
But wouldn't the more you get, make it more accurate?
But your standard deviation formula doesn't work. So you want it to be less than 10%.
So what is the actual correction factor?
Is that because
Or do we need to know?
the standard
You don't need to know the formula for that. You just need to know that there is a correction factor.
More people you have, it's smaller in standard deviation.
Okay, so let's go ahead and keep going. The second half of this unit, out of the 3, we're only going to do 2 this unit. So sampling distribution, second part's confidence interval. Then all of unit 10 will be hypothesis testing. Once you get through those 3 things, you're done with all of the concepts for this whole semester. And we'll just apply those 3 concepts to different sets of data. So that's why I'm telling you, make sure that you understand each of one of the 3 branches, because it's going to keep repeating itself over and over and over. Okay, confidence intervals. So suppose we wanted to estimate the proportion of blue candies in a very large bowl. A very large bowl. Like, there would be no way that we could count all of them. So we could take a sample and then compare the proportion in our sample and just mirror that to the population. The first definition, or the first thing that we'll learn, is a point estimate. A point estimate is a single number or a statistic based on the sample data that is used to estimate the population characteristic. So in this chapter specifically, we use the word point estimate for the rest of the semester. In this unit specifically, our point estimate is p hat, which is our sample proportion. Point refers to a single value on a number line. It's not always close to the population characteristic due to sampling variation. So if everyone in here took a different sample, if I had a bowl of M&Ms that was like 10 feet in diameter, it was just a huge, huge bowl of M&Ms. Everyone in here took a sample of 50 M&Ms and you counted the blue ones. Everyone in here would get a different proportion. And so that's what these dots on the number line represent. All of you get different proportions or different percentages of blue candies or blue M&Ms out of the total. And the arrow represents, okay, there is an actual proportion of blue M&Ms. That is true. That is accurate. And it's kind of like the goldfish example when we counted the goldfish. 47% smile and 53% don't. But when you took a sample, all of you got different numbers. And so they're close to 47%, but they're not always exact. And that's what sampling variation is that when you take a sample, it may not be exact, but it is close. And so when you take that point estimate, what confidence intervals represent is how confident are you in your sample. So there are different ways that we can calculate what we call a confidence interval, where that's going to vary. So you can have 95% confidence, you can have 90% confidence, you can have 80% confidence that the true number of blue M&Ms, or the true proportion of blue M&Ms, is within this range of values. So you're going to be able to calculate an interval that you know with 90% confidence that the population is somewhere between these two numbers. So a confidence interval for a population characteristic is an interval of plausible values for the characteristic. And the primary goal of a confidence interval is to estimate an unknown population characteristic. So maybe we want to find out, I don't know, what's a good example? Maybe we want to find out how many people in the world brush their teeth 3 or more times a day.
Why would you do that?
Because you're just curious. Like, you've always wanted to know that. And you've,
Why would you go 3 times a day?
Clean hygiene.
right. It's just something you've been wanting to know. But like, that is a population proportion that no one knows. I mean, what is that number?
Does anyone in this room brush their teeth 3 times a day or more?
Sometimes I do.
Sometimes I do.
Okay, honestly though, I love brushing my teeth.
Yeah.
It feels great. It feels so like clean.
So let's say at least 3 times a week they brush their teeth more than 3 times a day.
Okay, that's
Like on a weekend, if I had lunch or something, I'll brush my teeth again because I want to.
Yeah, like I'll brush it 3 times if I have like a.
Maybe we could say 2 times a day. How about that? Okay, 2 times. So, stop talking. So, all of that to say, if we're making it 2 times a day, that is a number that we do not know. So, maybe we think that it's 83%. That's what statistics tell us, but we're just not sure. We don't know if that's accurate or not. So, we're going to create what we call a confidence interval and mathematically solve based on a sample where you can say, I'm 90% confident that between 80 and 87% brush their teeth at least 2 times a day. Something like that in the world. Yes. So you can actually make that assumption to the population if you take your sample in a correct way. So I'm going to show you the steps and the processes that you can take that this would apply to the entire world or to the entire population. You just have to hit a checklist of things in order to apply it to the population. And so it's constructed so that with a degree of confidence, the actual value will be between that interval. And you're going to be able to choose what degree of confidence you want. You could have a higher confidence or a lower confidence. And then I'll show you how that affects your interval.
You choose it, or does it like depend on the problem?
Sometimes it'll be told to you. Yeah. It'll say do a 90% confidence interval. Okay, so hypothetically, I think most of you probably know my age, but I want you to let's think of someone else. Let's think of Dr. Moss, because I don't think anyone in here actually knows his age.
He's
I do.
58.
So, if you were thinking of Dr. Moss, rate your confidence percentage on guessing his age within 10 years.
100%.
90.
So what do y'all think for Dr. Moss?
Over under 74.
But like,
Over under 10 years is
I would say
70.
73-ish.
I think he's 74.
so within 10 years, like margin of error, 10 years, you're like 100% confident you can do that.
No.
10 years?
No.
10 years. Yeah.
Okay, but what if
He looks so young.
I said within 5-year margin of error?
80?
So what's happening to your confidence level?
It's
It's going down, right?
Specific.
If I said within 1 year,
You're less likely to judge. Within 2 days.
Right.
marijuana.
So all of that to say, when you're doing a confidence interval, you're going to have, so with a larger margin of error, or like a larger interval, you're going to have higher confidence. Because if I said, well, you can be right within 10 years, then you're going to have pretty high confidence. But if I said, well, you only have a 1 year margin of error, that means you have to guess it correct within 1 year, then that means you're going to have a lower confidence. So keep this example in the back of your mind because this concept comes up constantly. And people forget it. People forget that the larger your interval, the higher your confidence. The smaller your interval, the lower your confidence. So that makes sense logically, but I don't want it to be something that you memorize and then forget on the test. I want it to be something that you understand. So think about Dr. Moss, think about his age, and then what goes with that. If I'm giving you a 10-year margin of error, you're so confident. If I'm giving you a 1 year margin of error, you are not confident. So think about it that way. I'm going to skip this. Okay, so now we're going to talk about the equation to calculate the confidence interval. We're going to start with a 95% confidence level.
Is that constant?
No, it'll vary. Typically it's like 90, 95, 98, but it'll tell you. Yeah, the pages. It's because the PDF already had page numbers and I couldn't delete them. Okay, when you're talking about a 95% confidence interval, you are wanting the middle 95%. So it is the middle 95%. This is a z-curve right here. So 0 is my mean. And then my standard deviation is 1, like a standard normal. So we're converting everything to z-scores in this unit. And we want the middle 95%. That's what a 95% confidence level is. So if I have the middle 95%, then that means that the lower tail, like the area above and below the middle 95%, is 0.025 and 0.025. So what it's doing is it's taking the 100% minus 0.95, which is 0.05, and then it's splitting it in half to get 0.025. So that's what's left in the upper and lower area.
Okay, so what did you just do? Why did you do that?
To find out like what's in the area on the outsides. And you'll see why I do this here in a minute. So these right here, these two boundaries, like the upper and the lower tail, we refer to those as what we call Z star. So that's the Z score at the lower end of the confidence level and the upper end of the confidence level. So this is Z star. This is negative Z star. And so what that means is that's the lower and upper bound of my Z score.
Just those lines?
Yeah, the lines. The upper and lower boundaries of my confidence interval. Okay, so how do I figure that out? How do you find a Z score in your calculator? So not the area under the curve, because that's normal CDF. Inverse norm. Inverse norm. So in your calculator, what I want you to do to find these Z scores, you're going to go to inverse norm. I'm just going to find the upper one because the lower one's just going to be the negative. So I just want to find the upper one. So to find the upper one, the first number that you put in is a percentile, and a percentile is the percentage at or below that value. So what number would go in my first blank if I wanted to find this Z-score at the top end? Z star. Not 0.95, 0.975. How did you get that? Because you got this, which is all 95, and then you got this, which is 0.025.
Does it matter which one we do first? I think you said that.
You're only going to be doing the positive one in this
Your Z-score is
forever.
12.9.
You'll never do the lower one. You'll always do the positive one. So, an easy way to remember what number goes here, in my head, if it's a 95% confidence level, I think it's halfway to 100. Halfway to 100 is what I tell myself. Because if I'm at 95, halfway to 100 is 97.5. That's the number that's the percentile that is right here. Halfway to 100 from 95.
You just gotta include the bottom part.
Right, you just got to include the bottom part. So you think, what is this percentile? It's the confidence level plus half of the tails. Right. So you're adding in this little guy right here. Okay? This little guy. Or you're taking 100 minus this little guy right here. Either way, it works.
So when we find the Z-score, what does that give us?
So this right here is the upper bound of
That's
the
Z
confidence
star,
level.
that's what that means?
So we call this Z star.
So the Z-score is 1.96.
Yes.
Okay, so Z star.
Z star is 1.96.
Wait, I thought that found the Z-score.
Z star and Z score are the same thing.
So why do you?
Then why do they have two different names?
Because Z
Because
star is
Z star is
specifically
fun
for
and
confidence
sweet.
intervals.
And the other one would be the negative Z star.
Right.
Sorry, lady.
But what is that? Why do
So
we call that?
Z-score.
What does that help us? That just
We're
shows
we're
us
about
where
to get there. I know y'all got questions. We're gonna get there. I
thought star
promise.
was just the line.
We are gonna get there.
Like what your like area is between. It's like
Okay, I
0.95
thought-
is between 0.025 and 0.025.
Right.
I thought
And find the Z-score.
Okay, let's just bear with me. Come on, we'll get there. I promise. Yes.
Yeah.
So what this means is that 95% of the data is within 1.96 standard deviations from the mean.
Wait. 95% of data is within.
1.96 standard deviations from the mean.
So why is it?
Okay, so that is just, let's keep going, okay?
Wait, why is it 95%?
Because it gives us 95%.
But you added that extra tail. Where does
We
that-
didn't add a tail.
I thought we did define.
It's 95% within. So it's the middle 95%.
What is the? So that 1.96.
It branches out, remember, from the middle. You don't start at the left, you start from the middle. and then
Yeah.
move out.
Middle.
But when you're trying to find the area, you have to
Zero's in the
find
middle.
So that's the area.
0 is in the middle, and then it branches out. 1.96, 1.96. Within. Within means on each side.
Yeah. But why did you add?
You're confusing yourself, Travis. Let's keep going, okay? I promise you. I promise you. We just get through it and you will understand it. I promise. Okay, so here we have a sampling distribution, and it's normally distributed. In the center, we have our population proportion. So this is the mean of my sampling distribution, because remember the formula that we learned. The mean of our sampling distribution is our population. Always the middle. So, mean of my sampling distribution. This guy, this normal distribution, we call as our sampling distribution.
Yes.
Good.
I get that.
Good. Okay. So, the line represents 1.96 standard deviations below and above. That creates the 95%.
Whoa.
So, hold on. Please don't talk right now. Just want to explain it. So, I took a sample and I got this p hat right here. So, let's say maybe the true proportion of people that brush their teeth at least twice a day is 83%. I took a sample of 100 students at PCA and I got 76%. Then I create a 95% confidence interval around that. So I take a sample, it's different than my population. I go up 1.96 standard deviations, I go down 1.96 standard deviations.
So is this still connected to the other?
Yes.
This would be like a
So
drawing.
here's my 95% interval that I took when I took my own sample. Does it capture the 83%?
Wait, is that included in it?
Oh.
So here's my interval, okay?
It is.
So I got 76. The real one is 83. When I did my confidence interval based on my 76, maybe I got 72 to 85. So I think it's between these two numbers. Does it capture the true one?
Yeah.
Yes. So that is good. That is good. So my interval captures the true proportion. So that is why we do confidence intervals, because it gives us some leverage to say that I am 95% confident that the true number of people in the world that brush their teeth at least twice a day is between 72 and 85. And so 95% of the time, it's actually going to capture the true proportion. So if there were 100 people in this class and we each took a different sample, like we went out to the ends of the earth and we took different samples, 95 out of the 100 of us would capture the true proportion, and 5 of us would not. So here's a different one. This is when Avery took her sample and she got 85%. Because she went to TCA and 85% of them brushed their teeth. And then Courtney went to, what's the place we don't like? JP2, and she got 70%. Did that one capture it?
Sadly,
No, it did not.
You did a bad job.
You didn't do a bad job. It's because you're not 100% confident, and you can never be 100% confident.
Oh, yes, I can.
We can never be 100% confident.
I'm 100% confident.
So, what this means when we're developing this formula is that 95% of all possible samples will capture the true proportion. 5% will not. So that's what that little visual is trying to tell you. So confidence level. In this last example, confidence level was 95%. And it's going to vary with every example. You could be 99% confident. You could be 80% confident. It's going to be given to you. In every example, they will give it to you. If they don't, then my default is 95. If they don't give you the confidence level. If it's not given, use 95. But it'll always be given to you, especially on the AP test. They would never, ever not give it to you.
Why would you choose 95? Why is it 95% of your confidence?
It's just a good confidence level to use.
Is there a proof for that? Or just like
we just why the 12? No, we don't.
Okay.
Why the 12? No, it's going to vary.
I want to learn.
So you can have, it depends on how important it is to you. So if it's like a life or death kind of thing, like if I don't figure this out, then people will die, then I need to be 99% confident. I need to be really, really confident. But if I maybe want a smaller interval, then I could use a lower confidence. So it's up to your discretion, and as a statistician, you make that judgment yourself.
Can I
Yeah.
put that in my box?
Is that what they're called?
Statisticians? Yes. As a researcher, that is up to your discretion. That's something that you choose.
That's it.
So,
Statistician.
the confidence,
Is it a math thing to choose it, or is it just
personal. Okay, so the confidence level is what is given to you, or you just say it's 95%. That is associated with the interval estimate. That is the method used to construct the interval. So our confidence is in the method, not in one particular interval. And so a lot of times, I promise you this will show up on the AP test. There will be some sort of conceptual question that says, interpret the confidence level. So I want you to highlight this in your notes.
We don't have that.
Okay, then I want you to write this down.
It's just like the top one.
Okay,
Sorry.
I want you to write this down or highlight it. So, this is if I told you to interpret the level. So, not interpret the interval, interpret the level. I'm going to write this at the top. Interpret the level. So, tell me what the 95% confidence level means in your own words. What that means is that 95% of the time, so in the long run, 95% of the intervals will include the true population proportion. So when it says the actual value, the true population proportion. So if 100 of us went out to the ends of the earth and took samples and asked people, do they brush their teeth at least twice a day? We came back and we each calculated our own personal interval, because everyone's intervals are going to be different. 95 out of 100, about, I'm going to say approximately, because you don't want to use the word exactly. That's not good. About 95% of us would capture the true proportion of 83%, and about 5 of us would not. So does that kind of make sense? Yes. You just kind of got to let it sink in a little bit. Okay, the next thing that I have is a nice little visual. So the most common are 90, 95, and 99. Here's a little visual to kind of show you what it looks like. So these are the 100 people that went to the ends of the earth, and they asked people. So each one of these little horizontal lines represents all the 100 people that went out and took different samples. 83% is in the middle, because that's the researched true proportion of people in the world that brush their teeth at least twice a day. But these people did not get 83% in their confidence interval.
Does the 83% come before or after the testing? Like, is that the average of these, or do they know? that
83
before?
is like a known, so it's a parameter.
it's
It's like a
already
fixed value,
From past.
just from like past research, or like a number that's fixed, that's been researched and been proven. But you want to try and, yeah. And so if you have a confidence interval, you probably don't know that number, and you're trying to figure out that. So that's why you create a confidence interval.
Okay.
So based off of this, like, what kind of confidence level would you say was used for all of these?
I don't know how many.
93.
About 93%. Just because 7 of them, yeah. So 7 of them did not capture it. So just based off of this visual, I could say it's probably about a 93% confidence level. But like I said, it's not always exact. So it could have been a 95% confidence interval and then just 2 extra. But just the word exactly is, you want to use the word approximately whenever you're doing that. That's why I did a little squiggly in a 93. Yes?
Tilde.
How is that actual interval the mean of all the different things you would get?
No, the interval is going to be based on a formula that I'm about to show you. Okay. Okay, remember these sampling distribution properties, the mean, the standard deviation, those are given to you. And saying that the sampling distribution is normal. So these are all past things that we've learned. These are also the conditions that must be true in order to calculate a confidence interval. So this is the, like if I were to write words for the formula, these are the words. Statistic plus or minus critical value times standard deviation. This is the formula that you will use for confidence intervals. So this right here is on your formula chart. So the words are on the formula chart. The words are on the formula chart. Because we're going to take, so this formula is used for all confidence intervals for the rest of the year.
So it changes.
So like what you input in is what changes from chapter to chapter.
Did you suggest them?
So if you look, whenever you see sample mean and sample proportion in this top chart right here. This unit, we're talking about proportion. So I'm going to go to sample proportion, and then this is the standard deviation that they give me. Okay? So when you're talking about a confidence interval, I know that I'm talking about p hats. So that is my point estimate. I want you to write that in. So point estimate. That is the proportion that you get when you take a sample. And that'll be given to you in the problem. The z critical value is my z star. So this is my point estimate. The Z critical value is the Z star, so that was like the 1.96. And it'll get to the point where you kind of just memorize it because you use 95% a lot of the time. So it'll always, anytime you're doing a 95% confidence level, your Z star is always 1.96. And then this is the standard deviation of the statistic. However, when you're doing confidence intervals, do you know the P? Do you know the population?
Yeah.
Is it given to you? No. The answer is no, but you'll find that out.
They said that
So,
In the-
it's given to us.
it won't
the
be,
other one.
in a confidence interval problem, it won't be given to you.
In the sampling distribution.
It'll just give you a sample. So I'll show you, when we do an example, I'll show you what is given to you. We'll get to that in a minute. So I want you to add hats to confidence intervals. So add a hat here and here. P hat 1 minus P hat over N. So if P is not given, use P hat. So for all confidence interval problems, you're going to be using P hat. I know this is a lot of information, but once we start doing problems, it'll make sense.
So you start out by trying to use the P, or no? You just go straight to P hat.
In confidence interval problems, you have to use P hat. For the other two concepts, so sampling distribution and hypothesis testing, which we do next, you use P.
Okay,
So this middle, like this second section, you only use P hats because that's all you have. So you can go and try to use P, but you won't have it. So you'll quickly realize I don't have P, so I have to use P hat.
And that P hat's the same as,
Kind of like P hat is your default if you don't have P.
that's the same as the beginning of the formula.
Uh-huh,
P hat.
exactly. This whole thing so right here, this is called standard error. So I want you to label that as standard error.
Okay.
Multiple choice problems will say, what is the point estimate? What is the standard error? What is the margin of error? And those are vocab terms that you need to know. They're not hard to find. You just have to know what they mean. And then this whole thing, the whole thing circled is called margin of error.
Oh.
So we've got four things. We've got four things. P hat in the beginning is my point estimate. My point estimate is also always in the center. It is always the center of the interval. So my interval is always centered at P hat. Then it adds margin of error and it subtracts margin of error.
How do we know when to actually make that?
Okay. Critical value Z star, we already calculated that. It's found from the confidence level. It's the upper Z score, which is why we put in the 0.975. So if I wanted to find the Z star for 90% confidence interval, what would I type in? I would put in inverse norm of halfway to 100 from 90, so 0.9501. What do you get?
1.6448.
648.
6448.
Okay.
I don't wait. How many does?
I've just memorized these. 3. 95, you've already told me is 1.96. What about 99? What would I put in? Inverse norm. Inverse norm. 0.99501.
2.576.
2.576.
Were these on that graph that we had, or that's
Mhm.
something completely different? These?
Yeah, they're
They
still
are?
the same. You could still use those,
Those
but
graphs are
Oh.
just there to trick you up.
I don't like the graph.
Those don't help.
Okay, so what we're gonna do, and we'll do more of this next class, we'll get some practice, but I'm gonna show you the steps first. And then we'll go through one full write-up at the end of class today. So there are, like I think I said this before, but your free responses will start being what we call a write-up. And it's basically almost a full page of things that you go through and steps that you go through to create a confidence interval or a hypothesis test, which we'll do next chapter. So there are steps that you have to go through in order to create what is a confidence interval. The first step is always checking your conditions or your assumptions. You can use either word, doesn't matter. So there are 3 conditions that you check whenever you're doing a confidence interval write-up.
Are these steps written?
Yes. The first step is that you say that your p hat is a sample proportion from a random sample. So you've got random sample. You check n p hat and n1 minus p hat is greater than 10. And then you say that the sample is less than 10% of the population. So those are my 3 steps that you check. Yeah. So just circle those, but we are going to do a write-up together. So I'm going to kind of speed through this because we're going to do a write-up together. Your sample proportion. It's the sample that you take.
Wait, you said that these are
So that was just 0.95.
It's going to be given to you in the problem.
I'll figure it out. It'll be fine.
You will, I promise. So you do your assumptions first. These 3. Then you do your calculations and then your conclusion. So confidence intervals have 3 steps. And I'm going to go through all 3 of them with you in a minute. The conclusion, you say we are blank % confident that the true proportion of people that brush their teeth at least twice a day is between, and then you put your lower and your upper bound.
110%.
No.
110%.
No, you will not get that.
Good one.
What if it's just I am what %?
Okay, so what I want us to do,
Um,
do you have this filled out on your notes or is it blank?
It's-
This next, so go to the next page.
Yes. It's
Okay, so this is from the slide talking about how well our U.S. colleges run. So it describes a survey of 1,031 adult Americans. The survey was carried out by the National Center for Public Policy, and the sample was selected in a way that makes it reasonable to regard as representative. Of those surveyed, 567 indicated that they believe a college education is essential for success. And it's asking me to create a 95% confidence interval on the next slide. Okay?
Sorry.
So what I'm going to do is I'm going to go through the steps. The first one is my conditions. And I always put a label at the top until, this is where we're starting. I always put a label at the top because until I just get to where this is all really easy for me, I need something to memorize and I need steps. So my first step is conditions. The first condition is that you're going to say either you have a random sample, so in the problem it's going to say random, or it's representative of the population. So you've got 2 options. So in this case, is it a random sample or is it representative of the population?
Representative.
Okay, so the sample of, what am I sampling here?
Adult.
Of adults. I sometimes hate this example because I would say like 99 out of 100 times it's a random sample. And so you would say the sample of adults is random or randomly selected. So I'm going to put that down below as like a little hyphen, randomly selected, because most times it's a random selection. This is like a weird example, but we include it because if you say that it's a random selection but it's not random, then you don't get credit for it. So there's 2 options. It's either representative or it's random. 99 out of 100 times it's random. But this particular example, it is not. You just got to check.
Does it have to say representative?
Yeah.
Okay, I just want to make sure.
So so that's condition 1. Condition 2, we are checking that the sampling distribution is normal. So n times p hat equals, my n is 1,031. My p hat is 567 out of 1031.
P hat always a fraction.
Yeah. So, or a decimal. 567 greater than or equal to 10. Good. N 1 minus P hat is 1031. What is 1031 minus 567?
What?
464.
464 out of 1031.
Wait,
so
what?
You lost me.
1 minus P hat. So just the
Where'd you
opposite.
get 1 minus.
Those are the two that you check.
I know.
Oh, that's what you're
It's
Where'd
not
the
461.
464 come from?
We subtracted 567.
64.
1031.
Yeah, we subtracted 1031 minus 464. So then I say the sampling distribution of adults is approximately normally distributed.
Wow.
No, since I was able to go. Since I was able to go.
The third one that you check is
Oh my gosh. You're so
the sample of 1031 adults is less than 10% of population.
So in this case, population is the world.
Yes.
Well, wouldn't it be Americans?
Yeah, you could say of adult Americans.
Do you have to write like?
They aren't too picky about it. In fact, sometimes they don't even check this assumption, but sometimes they do, so we always include it.
Oh, the college story.
Okay, that is all conditions. These three. The second step, so that's step 1. Step 2 is calculations. The first thing that you do is you name the test. So the name of this test is a 1 proportion, 1 prop, Z interval. No, 1 prop Z interval. So it is stat test A. Do not just choose Z interval. And you'll know, like it'll prompt you to put things in, and if you just choose Z interval, you won't have the information that it prompts you to put in. So you'll easily know. It's kind of like a trial and error. I promise you that you'll know which one to do when it comes time to it. Especially people will learn all of them, and you'll think, how do I know which one to use? But I promise you that it will come to you and you'll know. And so 1 prop means that it's 1 sample or 1 proportion. We're using a Z because we're talking about proportions, and then it's an interval. We haven't learned the test yet. We'll do the test next chapter. So 1 prop means 1 sample. Z means I'm dealing with proportions. We'll do T later. And then interval means I'm doing a confidence interval. So the first thing you want to do is name the test.
Wait. What did we put this in?
Hold on, we haven't gotten there yet. So I'm going to write the formula by itself. So if you need to go back in the notes, you can. But the formula by itself is P hat plus or minus Z star square root P hat 1 minus P hat over N. So you're going to write the formula by itself.
always.
Mm-hmm. You're going to put the formula plugged in. We have P hat, but what's the other piece of information that we need?
Z score.
The Z star.
Nice.
I get that by you have to show what you type in the calculator. Inverse norm. I'm just writing it below.
The area is.
So you type or you write below what you type in the calculator to get your Z star. So it's inverse norm. What number goes in the first blank? It's halfway to 100. So 0.975, 0, and 1. And you get 1.96.
Where do we get 0.975 from? I'm sorry.
So it's a 95% confidence level, halfway to 100. Yes.
How did you assume that it was the 95 thing? Because aren't we like?
The question said what
Oh, it did.
create a 95. Yes.
Okay.
So this is formula by itself. The next part, so then I say equals, formula plugged in. So P hat is, what is 567 out of 1031? We don't necessarily even need that, so I'm just going to put 567 out of 1031. Because you can write it as a decimal, or you can leave it as a fraction.
Wait, what'd you
Yeah.
0.55 plus or
Why'd you write that right there?
plus 0.549.
That's, I'm plugging in the formula. So plus or minus.
Oh, okay.
Z star is 1.96 square root. If you want to put it as a decimal, you can. I sometimes just leave it as a fraction, but it doesn't matter. 1 minus 567 out of 1031 all over 1031.
So the p hat is just the number it gives you over the total.
Mhm.
So we're in 1031.
Okay.
And equals. Now, you do not have to do any of this by hand because the one prop Z interval on your calculator does it for you. So go back to your calculator. X is your number of successes. So I'm going to put in 567. N is 1031. And confidence level is 0.95. Do not, listen, everyone look at me. Look at my eyes right now. When it prompts you to put in confidence level, you put in the actual level. So I put in 0.95. But when you're doing inverse norm, that's when you put in the 0.975. Do not put 0.975 here. Don't do the halfway to 100 thing here. So if it says confidence level, I'm doing exactly what it gives you.
Wait, what's 464?
567.
Yeah.
And you should get 0.5196. Do 4 decimal places. 0.5803.
I got 0.54. I got 4. Oh, why did this happen?
Which one did we look at?
The top.
Yeah,
That's my interval.
I got
Wait.
0.5499, which was the
Right.
567.
You should get a confidence interval at the top. Look at the line above that. Conclusion. So that was step 2. Step 3 is conclusion. My conclusion is a fancy sentence that says, you can say we or you can say I. Sometimes I like to use we because I feel like it's team effort. Like, we are 95% confident. I am 95% confident that the, here is where I insert the context of the problem. So what are we even trying to figure out here? I've just forgotten.
I've also
Something about American.
the amount of American
college
adults that show up to this class.
They think that
see.
a college education.
Oh, do they think
I
college
don't
is essential
think
for
that's
success?
what it was, Aiden.
Let me see.
Just read it.
Hello there, is there?
That the adult population thinks that college education.
That the
It's a new term.
true
Like it's changing.
proportion of adult Americans, y'all should all be writing this, who believe that a college education, yes, it's a lot of writing, is essential for success, is between. You can either leave it as a decimal or change it to a percentage. It doesn't matter. I'm going to leave it as a decimal. So it was 0.5 what?
450.
5196.
No, that's not that one. It's 0.5196.
0.5196
But it's not.
and 0.5803. And then you are done. So what you will change, what will vary from example to example.
Yeah, I got it.
This right here is my confidence level.
Subject.
Yeah.
Yes.
And then the values.
This right here is context, and it'll come straight. You do not change words. It comes straight from the problem. So context from problem. Don't get fancy and try to change things. It comes, you just copy paste it. And then lower and upper bound. So that's my interval.